Hello, hi dear Swift learners, how are you all? I hope that you all are fine, and I, Ritika, welcome you all here at Swiflearn. And today, what are we going to study? I'm going to tell you very soon, but before that, we will be having a tour on Swiflearn to see what is Swiflearn all about. So Swiflearn, it is India's most sincere learning destination, wherein we provide the classes for grade 1 to 10th. Here you will be getting live and interactive classes with personalized attention batch having 6 students at maximum. Apart from teachers, we also have an academic mentor team to track your progress, and the team will be helping you if you get stuck anywhere. Also, we cover your syllabus as per your school exam schedule so that you can perform amazingly well in your school also. Plus, there are some of the more key features which make Swiflearn all the more special. And these key features include a detailed progress report which gives you a detailed analysis of what you have been doing in these sessions, from homework, classwork, practice test, and what all things you need to improve. We have Swiflearn Academic Test Series wherein you compete with the students of your grade. You know your positions and you can work on yourself accordingly. You can also take unlimited practice tests which are available on the Swiflearn portal, and these tests they have two categories of subjective and objective, and these subjective tests they will further help you in writing the answers in your school exams. So please experience all these amazing features by booking a free trial class for yourself at Swiflearn. All you need to do is just download the Swiflearn app, select your grade, select the time according to your choice, and there you go with your free trial class. And if you are new to the channel of Swiflearn, kindly subscribe and press the bell icon so that you do not miss out on any update. Plus, if you like the video, kindly press on like button. Alright, so let us quickly begin with ammonia. Today we are going to have a study of compounds in which we are going to learn about ammonia. So objectives for today's chapter is we're going to see about occurrence and forms of ammonia, what are the physical and chemical properties of ammonia, how to prepare, and some of the tests for ammonium gas and ions, and at the last we will be seeing the uses of ammonia. Now, sometimes, especially in public toilets, there is a kind of very bad and pungent smell coming, right, which is unbearable, right? So that pungent smell, it is due to the decaying of organic matter, and that is because of ammonia. Alright, so it is because of this bacterial decomposition which is occurring, okay, the bacterial decomposition of urea which is present in urine. Ammonia is a compound of nitrogen and hydrogen. And how is it created? It is created by decaying of animal bodies and vegetables. Ammonia, it is a covalent atom, and it is seen as a dot structure. So covalent, it is formed by sharing of atoms, and the molecular formula is NH3 with a relative molecular mass of 17 units. So as it is said that ammonia is a compound of nitrogen and hydrogen, okay, so here there is nitrogen and hydrogen, this is the formula, and then we have the relative molecular mass of 17 units, and this is how the structure of ammonia looks like. Occurrence, talking about where do we find ammonia. First of all, it is found in free state in some of the in the air, in some traces, and also in water. And in combined state, if we talk about, it is occurring in many compounds such as ammonium chloride. So here we have ammonia present in ammonium chloride in combined state. Talking about the forms of ammonia, we have two basic forms. First is in the form of gas, which is gaseous ammonia, and second becomes our liquid ammonia, which is liquefied ammonia present in the cylinders. Then we have liquor ammonia fortis. So what is this? This is a saturated solution of ammonia in water, also known as 880 ammonia. So saturated means no more solute can be dissolved. So it has ammonia up to a peak, and that is also known as 880 ammonia. After that we have laboratory beach ammonia. So it is diluted solution of liquor ammonia. So when we dilute it, it becomes laboratory beach ammonia. Now talking about preparation. So we can prepare this ammonia gas by heating an ammonium salt with caustic alkali. Let us see how. So if we take ammonium chloride and if we heat by caustic alkali, we will be getting ammonia. So this is one of the most simplest preparation to get ammonia gas. And now here the ammonia gas, it can be generated in laboratories also by heating ammonium chloride by slag and slaked lime. Now here what are the things that we need to keep in mind? The ratio. So the ratio of ammonium chloride to slaked lime, it should be 2:3 by weight. And how to prepare it? First of all, we are taking very finely grounded reactants in a flask, okay, and when we heat this particular mixture, the ammonia gas will be evolved. Okay, so this is our reaction. This will be going like this, and this is the pictorial or diagram representation. Okay, so when we are heating the mixture, we will be getting what is known as ammonia gas. Now drying of ammonia gas. So we got the ammonia gas. How to dry it? We dry it by passing through a drying tower containing lumps of quicklime. Okay, so when it is dried, it can be collected by again downward displacement of air. And this collection thing we have already studied in our previous chapters, that how to collect the gases which are given to us. Next, some of the precautions that we must take while forming this gas is, first of all, the ratio we should be very careful about. This ratio of reactants, it should be 2:3 by mass, and the flask, it should be tilted in such a way that the water formed does not trickle back into the heated flask, which means the water should not again go back to the flask, otherwise we won't be getting the required products. Preparation of aqueous ammonia. So aqueous means just diluted in water. So aqueous ammonia, it can be prepared by this dissolving the ammonia into water. It is very simple. Okay, so see, here we are getting the ammonia gas, and when we dissolve it in water, we will be getting the aqueous ammonia. What is the procedure? Water is taken in a container and only a small portion of the mouth of funnel is dipped in water. You can see we have dipped it in water, but only a small portion. Then for a moment, pressure in the funnel above water level decreases and water rushes into funnel. Due to this, rim of the funnel loses contact with the water. The funnel comes in contact with water again because ammonia pushes the water down. So what is happening is, first of all, it is just above the water, and then after a moment it again gets into the water, and when it gets into the water, the ammonia dissolves in water without back suction. Back suction means again going back. So it doesn't go back and it dissolves in the water, and that is how we get aqueous ammonia. So let us study about this through a video. Okay, and this process of manufacturing ammonia, it is known as Haber's process. So let's have a look at it.
You have likely produced ammonia in the laboratory from the thermal decomposition of ammonium chloride or from the reaction of ammonium and hydroxide ions. Have you ever wondered how ammonia is produced on an industrial scale? In this lesson, we will learn about the Haber process to produce ammonia, developed during World War I by Fritz Haber and Karl Bosch. For their efforts and contributions to developing large-scale industrial processes, they were awarded with Nobel Prizes in chemistry. The Haber process is the industrial process for the manufacture of ammonia from hydrogen and nitrogen. Hydrogen is obtained from the reaction of methane and steam, producing carbon monoxide as a byproduct. The hydrogen produced from this reaction also reacts with oxygen from air, producing water and leaving nitrogen behind. Recall that air is 77% nitrogen. These gases are then compressed and delivered to the reactor, where ammonia is produced. These gases are then cooled down and ammonia is liquefied, ready to be tapped off. Unused hydrogen and nitrogen are recycled back to the reactor. Let's revisit this reaction again. Note that this is a reversible reaction and that the forward reaction is exothermic. The Haber process uses Le Chatelier's principle to maximize ammonia production while keeping operating and production costs in mind. Le Chatelier's principle tells us that increasing pressure will favor the side with fewer moles. For our case, the production of ammonia. It would make sense to conduct the reaction at a very high pressure, but we must also remember that it is expensive to build and operate a plant that can withstand such high pressures. Therefore, a compromise pressure of 200 atmospheres is used. Let's keep Le Chatelier's principle in mind. What do you think is the best temperature conditions to maximize ammonia production? Please pause the video to think about this and resume once you are ready. Since the forward reaction is exothermic, it would make sense to conduct this reaction at a low temperature. The compromise temperature is 400 to 450 degrees Celsius, which is not exactly low, but not too high. If a low temperature were used, the rate of reaction would be very slow, though the exothermic reaction would be favored. It would actually take a long time for equilibrium to be reached, so a compromise temperature of 400 to 450 degrees Celsius ensures that the reaction proceeds with sufficient yield. The yield of this process is 10 to 20%. Remember from the introduction that unused gases are recycled, so no reactants are wasted. As well, an iron catalyst is used in this process. The presence of the catalyst does not affect the position of equilibrium, but increases the rate at which equilibrium is reached. In conclusion, the Haber process is the industrial process to produce ammonia from hydrogen and nitrogen. It is conducted at 400 to 450 degrees Celsius and at 200 atmospheres in the presence of an iron catalyst. These are compromise conditions in order to maximize ammonia production and economic profit.
Alright, so we just now saw that it is the Haber's process which is used in industries mainly to produce ammonia using hydrogen and nitrogen gas. Now let us move forward. Okay, so this is the procedure which is shown in short. Okay, the ratio is shown 1:3. So we are taking nitrogen and hydrogen, okay, and we are providing the condition of 450 to 500 degrees Celsius at 200 atmospheric pressure with the catalyst being iron. The gases are being cooled and the ammonia, it turns into liquid, and we are taking liquid ammonia. And the unreacted gas, it is again recycled so that it can again take place in reaction and we get the ammonia. Next, physical properties of ammonia. First is as standard temperature and pressure. Ammonia, it is a colorless gas and it has a very kind of pungent and choking smell. Its nature is alkaline. Then it is very well soluble in water. The melting point of ammonia, it is minus 77.7 degrees Celsius and boiling point goes like minus 33.5 degrees Celsius. talking about the nature, it is a non-poisonous gas and it brings tears in our eyes sometimes when we inhale this gas. Now, we just now saw that ammonia gas, it is very well soluble in water. So how do we prove it? It can be proved by fountain experiment. Okay, so what is the procedure? The dropper which contains the water is squeezed. Okay, then what is happening? When a few drops of water it enters the flask, because ammonia is very well soluble in water, it gets dissolved, and because of this a vacuum is created in the flask. And ammonia gas, as I told you, it is basic, so it will be changing red litmus solution to blue. So this is how our experiment would look like. Okay, so this becomes an alkaline solution of ammonia which turns red litmus blue. Now, chemical properties of ammonia. First is it is flammable in air. Okay, next becomes on thermal decomposition. Okay, on decomposing we again get back nitrogen and hydrogen. Next is ammonia. It has natural power to give its lone pair of electrons to nitrogen to different atoms, and it is acting as a Lewis base. So how does it act like a Lewis base? Let us quickly see through a video.
Why are ammonium salts important? Well, if you've eaten anything before studying today, whether it was fruit, vegetables, bread, or something more processed, at least some of the crops that were grown to make your food, or perhaps feed the animals that went into your food, were almost certainly fertilised using an ammonium salt. To understand something, we need to know how it's created, so let's start there. You might have already guessed that making an ammonium salt starts with ammonia, NH3. Ammonia is a base. A weak base, yes, but a base nonetheless. So here's the first question. Can you remember what a base reacts with to produce a salt, and so suggest what we do to ammonia in liquid form to make an ammonium salt? Pause the video and have a think. Well, if you worked out that we react ammonia with an acid to produce the salt, you're absolutely right. Let's look at the reaction with the common acid, hydrochloric acid. Being a strong acid, this dissociates in solution to form H+ and Cl- ions. And what's another name for a H+ ion? That's right, a proton. The ammonia molecule can accept a proton, that's what makes it a Lewis base. And we now get an ammonium ion with 4 hydrogens and a +1 charge. Now here's another question. What is this new ammonium ion going to be attracted to that's present in the solution? Pause again and think. The answer is the chloride ion, which has a -1 charge. Now remember your ionic bonding. What are the ratios going to be for the ammonium chloride salt that is created? It's 1:1. The +1 charge of the ammonium is cancelled out by the -1 of the chloride, meaning ammonium chloride has this formula, NH4Cl. Here's the reaction. Ammonium chloride is an important salt because it's a main component in zinc-carbon batteries. Now here's your main challenge. Let's think about 3 other popular ammonium salts. Ammonium carbonate is an ingredient of smelling salts, which are not used much these days, but in the past, people used to inhale their vapours when they felt faint. Ammonium nitrate is an important fertiliser, and ammonium phosphate is not only a fertiliser, but can be used to flame-proof wood and clothes. So here are the carbonate, nitrate and phosphate anions. Can you write the chemical formula of the matching ammonium salt? Pause the video while you write down your answers and resume when finished. The carbonate ion has a 2- charge, so to balance this we need 2 ammoniums. The nitrate is -1, so here we have another 1:1 ratio. And the phosphate is 3-, so 3 ammoniums are needed. Pay attention to the use of brackets here. How did you do? As well as being a fertiliser, ammonium nitrate is also used to make explosives, but it's fair to say you won't be doing this in the lab until you become a very experienced chemist. All of these salts are formed in a similar way to that we've already talked about, by reacting liquid ammonia with the acid in question. Here's a final little challenge. See if you can balance the final equation. Pause and continue when ready. Here's the answer. How did you do? You might have learnt that an acid plus a base gives a salt and water, and that's quite right most of the time. But interestingly, as you can see, these reactions do not yield water, although it will still be present as a solvent. All of the atoms that make up the reactants come together to form just the one product, the ammonium salt. Speaking of water, all of these simple ammonium salts are highly soluble in it and form solutions, so to get solid salt crystals we'd have to evaporate the water. The exception to this is this complex looking salt called ammonium hexachloroplatinate. Don't try saying that with your mouth full. It's used for coating objects with precious platinum metal.
Alright, so here we just now saw that how ammonia can give the lone pair of electrons, okay, of nitrogen to different atoms, and how does it act like a base, Lewis base. Now we're going to see uses of ammonia again through a short video. What are the uses of ammonia? Let us quickly see.
We have previously learned about the Haber process as the industrial method to produce ammonia. Why do we need such large quantities of ammonia, and why is it so important? Ammonia is used to produce fertilizers, nitric acid, and certain household cleaning products. Ammonia is also used as a starting material for explosives and many pharmaceutical products. Nitrogen is important and essential for plant growth. Although air is approximately 77% nitrogen, plants cannot breathe it in. Instead, it must be dissolved in water and absorbed through their roots. This is done naturally by lightning and by certain types of bacteria, though it does not happen often or fast enough to sustain crop growth and hence food production. Fertilizers are used to increase the nitrogen content of soil, or, in other words, make it more fertile. Livestock manure has been traditionally used as natural fertilizers, but this has become too difficult provided the massive size of many crop fields. Two very common artificial fertilizers are ammonium nitrate and ammonium sulfate. And you got it, they are made from ammonia. Ammonium nitrate is made from ammonia and nitric acid. Ammonium sulfate is made from ammonia and sulfuric acid. The constant production of these fertilizers is very important to sustain global food production. Nitric acid is also manufactured from ammonia in a series of steps. First, ammonia combines with oxygen over a platinum catalyst to produce nitrogen monoxide and water. Then, nitrogen monoxide further combines with oxygen to produce nitrogen dioxide, which is a brown gas. Lastly, nitrogen dioxide and oxygen dissolve in water to form nitric acid. By combining these equations, we get this overall reaction to produce nitric acid from ammonia. Nitric acid is used in the production of ammonium nitrate and other nitrate-based fertilizers. It is also used as a starting material for many explosives, a common one being TNT or trinitrotoluene. Nitric acid is also very important for the pharmaceutical industry. It is also used to produce certain dyes. These dyes are used as food coloring in the textiles industry and even as indicators. Royal water, or aqua regia, is a mixture of 1 part concentrated nitric acid and 3 parts concentrated hydrochloric acid. In the laboratory, it is used to clean glassware, but a much more interesting application is its use in the purification of gold and platinum. Very dilute solutions of aqueous ammonia, approximately 5 to 10% weight by volume, are commonly sold as household cleaning products. You may have encountered household ammonia in your own kitchen and in your bathroom cleaning products. So to recap, ammonia is used for the production of cleaning products and pharmaceutical products. Even more importantly, ammonia and the fertilizers we produce with it are vital to sustaining global food production. Our world population is growing massively, and without such agricultural technology, we would be even less able to prevent famines.
Okay, so we saw uses of ammonia. Now we're going to recap. So ammonia, as we saw, it is used in production of urea, some dye, plastic and rayon industries. Then it is massively used in production of fertilizers, explosives and sodium carbonate. We use to produce nitric acid, plus it is also used as refrigerant in ice plants. Okay. Then it is used in furniture industry as a purging operator for furniture and glass surface, and in labs for a reagent purpose. Next, test for ammonia gas and ammonium ion. So this ammonia odor, okay, of a compound, it is effectively perceivable, having a characteristic pungent smell. So for test, we get a very pungent smell, and that is how we can identify if ammonia is present. And also it turns wet red litmus blue, and it moist turmeric paper brown in color. Next is when glass rod, it is dipped in ammonium solution and we hold it near the vapor of an acid. So HCl gas, it will be giving thick white fumes, and that is how we will be testing the presence of ammonia. Now some of the questions. Explain why ammonium nitrate, it is not used in preparation of ammonia. So because this ammonium nitrate, it is highly explosive in nature, okay, and it again dissociates itself into nitrous oxide and water on heating. So we do not use it in preparation of ammonia. Name the compound normally used as drying agent during the process. So we use quicklime. How is ammonia gas collected? So it is collected by downward displacement of air. And why the ammonia gas, it is not collected over water? Because ammonia gas is highly and very quickly soluble in water. Give the name of hydride of nitrogen. So nitrogen hydride is ammonia. Which reactants are used in laboratory for preparation of ammonia? So we use ammonium chloride and slaked lime. What is the vapor density and nature of ammonia? Ammonia, it is alkaline in nature, and the vapor density of ammonia, it is 8.5. Next is which feature of ammonia molecule, it leads to formation of ammonium ion when we dissolve it in water, and name the other ion which forms when ammonia dissolves in water. So one molecule is ammonium and second is hydroxide. So in ammonia molecule, what is happening? One lone pair of electron, it is there from nitrogen atom. Okay, and this particular lone pair, it leads to formation of ammonium ion. In our human body, the ammonia is produced naturally. It is used to make protein and some of the molecules in our body as a building block. And it can also be dangerous if it spoils cell in our body. So what are the things that we have learned today? We learned all about ammonia, the uses, the properties, the occurrence, preparation and some of the tests. Right, so I hope you might have understood everything that we have learned in today's class. We will be meeting in the next class, in which we will be learning a bit more about some other compounds. So till then, keep studying, keep learning, and let's meet in next session. Thank you everyone.